Let's start with an example that might seem obvious to some of you, but it's really important for when we study square roots. We have here a 4 and we have here negative 4. Well, we know very clearly that the one on the right is a negative 4 because we see a negative sign. But we don't see a sign on the one on the left. So what's the sign of that? Well, if there's no sign, we know that that's positive 4. If there's no sign, once again, we know it's a positive 4. The plus sign is basically assumed. For square roots, we have the exact same situation going on. This time, let's look at not 4, but square root of 4, or root 4. We have root 4 on the left and negative root 4 on the right. What is the answer to this? Well, from the previous video, we know what square roots are. So we know that the one on the left, that's equal to the square root of 2 times 2, which is equal to root 2 to the power of 2, which is simply 2. 2 squared is equal to 4, so square root of 4 is equal to 2. But for those of you that might be catching the pattern, that plus sign from the very beginning, because remember the plus sign is assumed, that plus sign is going to follow us all the way down. So that plus root 4 is equal to plus root 2 times 2. That's equal to plus root 2 to the power of 2, which is equal to plus 2. That plus sign follows the entire time to make sure that that whole thing is positive. Now that we've written positive on the left, let's look at the one on the right. We have negative root 4, which is equal to, that's root 2 times 2, which is equal to root 2 to the power of 2. But we know that that whole thing is also negative. The sign follows the whole way through. So I'm going to write negative root 2 times 2, which is equal to negative root 2 to the power of 2. And that whole thing is equal to simply 2, but it's not just 2, it is negative 2. The sign follows the whole way through from the top to the bottom to make sure that negative root 4 is equal to negative 2. So basically, this negative sign is kind of acting as if the radical, which is that cool looking thing on top of the 4, is a parentheses. Because the negative follows all the way down, just like how a negative sign outside of parentheses would follow all the way down too. Once again, if you have a negative sign outside the radical, that result is going to be negative as a result. So this brings us to a really important distinction that's really similar to a problem that a lot of people had a lot of trouble with in the previous video. When they ask you for the square roots of 4, that means that the answer is 2 and negative 2. Why? Well, it's because when they ask you for the square roots of 4, they're asking you for any number for which if you square it, it becomes 4. If you square 2, 2 squared is 2 times 2, which is equal to 4. And negative 2 squared, remember how the negative sign's inside the parentheses, that's equal to negative 2 times negative 2. The negative times negative becomes a positive, and that becomes 4 as well. Once again, positive 2 and negative 2, when you square each of them, they both become 4. So they are both square roots of 4. Now, when they say find root 4, well, the answer to this is not negative 2. If they say find root 4 and find negative root 4, well, find root 4 is equal to root 2 to the power of 2, which is equal to root 2 times 2, which is equal to 2. Find negative root 4 is equal to negative root 2 to the power of 2, which is equal to negative root 2 times 2, which is equal to negative 2. Find root 4 and find negative root 4 are different things, and neither of them are the same thing as what's on top. Keep that in mind. It's a very important distinction that a lot of people have a lot of trouble with. It's very important that we have this distinction really clear from the very beginning. Now that we know that there's positive and negative square roots, let's look at an example problem that shows us exactly what that means. We have negative root x is equal to negative 5. What is x? Well, this might seem really difficult, but it's actually not that bad. Let's ignore the negative sign for now. Whatever is the x, that has to be 5 to the power of 2, because the square of x is equal to 5. So, bringing the negative sign back in, if we have negative root x, that's equal to negative root 5 to the power of 2, because once again, the square root has to cancel out the square, and we have 5 as a result. And we know simply that negative root 5 to the power of 2 is equal to negative root 25. 5 to the power of 2 is 5 times 5, and that's equal to 25. Well, we have the x and we have the 25. So we know that x should equal to 25. Just to check our work, just to make sure we're doing it all correctly, let's go the other way around. We have negative square root 25. That's equal to negative square root 5 to the power 2. Because remember, 25 is 5 to the power 2. That's equal to negative 5 because the square root and the square cancel out. And that whole thing is equal to simply negative 5. It checks out, so we did it correctly. So that's how we solve this example problem. And just to recap with some vocabulary, every positive number has two different square roots. One is positive and the other is negative. For example, the square roots of 36 are 6 and negative 6. Both of them, if you square them, become 36, so they're both square roots. Now, instead of a review, I'm just going to give you some questions to think about. Does every number have two different square roots, one positive and one negative? We know that that's the case for every positive number. Is this the case for every number? Like 0. Like, for example, a negative number. Finally, what would happen if you took a number, found its square root, and then squared it? Would you get your original number? Remember that square roots and squares are the opposite processes of each other. It's like adding and subtracting, multiplying and dividing, square roots and squaring. All these are opposites, so I'm wondering whether you get the exact original number. For example, if you had 3 and you multiplied it by 2 and you got 6, and then you divided it by 2 and you got 3, is this same reverse process happening in squares and square roots? There's a lot of questions to think about as we explore this new topic. For now, see you next time. Make sure to like, comment, and subscribe. Best of luck on the work.